Chute converter is a DC to DC converter that can provide multiple level of output voltage. Chute converter consists of two capacitor, two inductor, and two switch, which is MOSFET and diode. The problem statement in this final project is the chute converter has many active components and has higher switching stress to the switch. The main concern is to identify which controller is the best that give output voltage, has less settling time, rise time, ripple percentage, and steady state error, and made chute converter operating in high performance. For objective, we designed the high performance chute converter using MATLAB and use PI, OCC, and FLC in the chute converter. And the third one, make analysis and comparison the controller of the chute converter. PI controller use the arrow signal as the control loop feedback. The generated control signal is sent to the system and the operation are repeated until the steady state error is minimized. So, for OCC controller, it uses constant frequency and the diode voltage is integrated and compared with a control reference. As soon as the integrated diode voltage reaches the control reference and the transistor is turned off and the integrator is reset to 0. For the FLC controller, fuzzification, rule-based, and defuzzification are the three main components of the fuzzy logic controller. The error and the change of error enter the FLC block to compensate the error before entering the MOSFET for completing the cycle. So, from the output voltage from the three controller, the best value for overshoot is PI controller. And the best value for settling time is FLC controller. And the ripple percentage that has lowest value is in the OCC controller. So for the dynamic response chute converter, we have set two different value, which is 10 volt and 50 volt, to make sure that chute converter can operate in the two mode, which is buck and boost. This is the value of PI controller, OCC controller, and FLC controller. So, based on the dynamic response output voltage, the best settling time and rise time is FLC controller, but in the percentage of steady state error, PI has a best value. And we do a conclusion, all the system that we have done is stable because the output voltage doesn't change when we change the reference voltage. In conclusion, chute converter can do both modes, which are buck and boost. In closed loop, the best performance based on speed are FLC because it has a lowest rise time. In terms of accuracy, PI is the most accurate because it has a lower steady state error in output voltage. In OCC controller, it has a lowest ripple percentage but has highest overshoot output voltage.